Hi friends. Next point from the transition and inner transition element is what is the differences between the first, second and third transition series elements. They differs in their oxidation state here. You know that you can simply say that the stability of this compound of the first row differ from second, third rows in stabilization of their higher oxidation state in their compounds. Molybdenum shows fifth and the tungsten shows 6 compounds are more stable than chromium 6 and manganese 8. Here it can shows variable oxidation state. Molybdenum and tungsten from the second series element and chromium and manganese is the first transition series elements. Among these molybdenum and tungsten, molybdenum shows 5th and tungsten shows 6 oxidation state, and it is more stable than chromium in 6 oxidation state and manganese plus 8 oxidation state. Higher oxidation state of elements of first row is plus 7. Higher oxidation state of the first row element of the transition series is plus 7. Manganese shows higher oxidation state and it is plus 7. And third row, a maximum oxidation state shows ruthenium and osmium. It can shows higher oxidation state is plus 8. This is the differences between first, second and third rows elements. It can shows variation with their oxidation state. Then extraction of metals. You know that how can extract of your metal? Metal, it is not present in free state. It is present in a combined state. It is present in their carbonates form, sulfides forms or their oxides form. And from this you can obtain pure metal from these carbonates, oxides or sulfides. Extraction of the metal, that means from the ore you can obtain pure metal by various steps, their concentration ore or reduction, roasting. By this process you can separate your pure metal. Extraction of metals. Most of the metals are found in the earth crust in the form of carbonate, sulfates, sulfides and oxides form. Okay, and from this carbonate, sulfides or oxides forms you can obtain pure metal. The minerals, basically your ore is present in minerals form, and from this minerals you can obtain higher percent of the metal. It is called as a ore. What is mean by mineral? It is a naturally occurring substance and found in the earth crust containing inorganic solids is called as a minerals. Minerals is a naturally occurring substance and which is present in a earth crust, and in the earth crust some inorganic solids are present. It is called as a minerals. And the mineral containing higher percentage of metal, and the metal can be extracted in the pure form. It is called as a ore. It's a very simple one. What is mean by mineral? A naturally occurring substance found in the earth crust containing inorganic solids is called minerals, and the mineral containing high percentage of the metal from which the metal can be extracted economically is called as a ore. Gangue particles, that means what? The sandy, mud and other unwanted impurities which remains mixed with the ore deposit are called as a gangue particles. In this ore, some ore is not a pure form which contains some sandy ore is not a pure form which contains some unwanted impurities, sandy particles, and the unwanted impurities, sandy particles, mud particles which remains mixed with the ore or deposited, and it is called as a gangue particles. Concentration of the ore separated from the gangue material using different methods like washing by using water molecule, and then hydraulic classification, magnetic separation, flotation process. Concentration of the ores, that means what? You can take your ore and you can grind it and crush it and then wash with water. There are several methods of the concentration of the ore. That means what? You can just remove unwanted sandy impurities from this ore. It is called as a concentration of the ore. Concentration of the ore is separated from the gangue material using different methods there. You can do washing, hydraulic classification, magnetic separation, flotation process. There are several methods involved for the concentration of the ore. There are 4 methods. Okay. You want to extraction of iron from hematite. You want to extraction of iron from hematite. How can extracted your iron from hematite ore? Why your iron ore is hematite? Because the percentage of iron in hematite is in maximum. That's why ore of the iron is hematite. And what is this? Fe2O3. What is the composition of hematite ore? It contains some impurities, that means gangue particles. Which are the gangue particles here? Fe2O3, SiO2, Al2O3 and phosphate. This is the composition for the hematite ore. Fe2O3, that means this is the ore and which contains some impurity. Which are the impurities? Al2O3, phosphate and SiO2. That means this is impurity, that means gangue particles. And you want to separate this from this hematite ore. There are methods or steps involved. Separation of or extraction of pure iron metal from its hematite ore. Which are the steps here? This is your iron ore. You just crushing and grinding. And then concentration takes place. There are 4 methods of the concentration of the ore. First, magnetic separation, gravity separation, leaching, flotation. All these methods discussed in isolation and extraction of an element chapter in your 12th syllabus chapter involve all these method. Magnetic separation, that means what? Gravity. How can gravity separation, leaching, flotation, all these process involved in the chapter isolation and extraction of an element in the chapter. We will discuss in next chapter. Then concentration. After the concentration, you can do the reduction of this ore, and reduction takes place by using reduction by coke, reduction by Cu, reduction by heat, reduction by aluminium, reduction by electrolysis. You can do after the concentration of the ore, you can do the reduction of this ore by using reduction by coke, reduction by carbon monoxide, reduction by heat, reduction by aluminium, reduction by electrolysis. Okay. Then after the reduction, you can refining. There are after the reduction, you can do the reduction with the help of this, and then after the reduction, you can refine this ore by which process? Liquefaction, distillation, oxidation and electro refining. After the reduction, you can refine your ore by which process? Liquefaction, distillation, oxidation, electro refining. All these points you also discuss in extraction of and isolation of an element chapter. Okay, in detail. Then you got after the refining by liquefaction, distillation, oxidation and electro refining, you got your pure iron. Okay. Then extraction of iron from hematite are there are several steps there. First step is concentration of the ore. You can concentrate of your ore separated gangue particle from the ore by using different methods: washing, hydraulic classification, magnetic separation and flotation process there. Then roasting. Roasting, that means what? You can concentrate ore is heated in presence of air, and impurities get converted into impurities. They are sulfur and arsenic, and it is get converted into respective oxides there. Okay. Roasting, that means what? You can heated your ore in presence of air. There are some impurities like sulfur, arsenic, and this impurity get converted into respective oxides. And for example, you can see here basically roasting process is used for the extraction of the hematite ore. And how can extracted from the hematite ore? You can just see here. Okay, this is your ferrous oxide, and you can do oxidation with the help of air, and you can just heat, and you got here ferric oxide as a product in the roasting process. And third step is reduction, and I already told you reduction takes place by using reduction by coke, reduction of CO, reduction by heat, reduction by aluminium, reduction by electrolysis. You can reduce this ore, hematite ore. Then refining, there are refining several process: liquefaction, distillation, oxidation, electro refining. All these points we'll discuss in next video, and in detail we'll discuss in isolation and extraction of an element in this chapter.